Today's topic is the Batochromic shift. These are different shifts of the wavelengths, and this shift of the wavelength increases due to the presence of the chromophore and the oxochromic group attached to that particular compounds. So this shift changes the wavelength, changes the absorption of the UV lights, changes the frequency, changes the parameters regarding the shift regarding the wavelength, regarding the frequencies about the waves. So this is the importance in the case of the dyes, because dyes properties mainly focused on the its intensity and its colors. So the chromophore and the oxochromes interactions means there are two types of interaction. One is the chromophore and chromophore interaction, one is the chromophore and oxochrome interactions, which increase the length of the conjugations. Conjugations, what is the conjugation? Conjugations are present in the bond systems. For example, if you consider the benzene ring systems, in that benzene ring system there are 3 double bonds in that. Means due to these double bonds in the conjugation, means the alternating by double bonds, double bond, single bond, double bonds. I will show you what is the conjugations. For example, this is a structure having the only one double bond, having the only one double bond, means the double bond, single bond, single bond, double bond, single bond, single bond, then double bond, single bond, single bond. So this is not called as the conjugations. This is not called as a conjugation, because for the conjugation condition is that the condition for the conjugation double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond is a condition for this conjugation. If in this way, if the bonds are present, then that compounds can give the conjugations, otherwise other compounds cannot give the conjugation. Okay, so this is all about the chromophore and oxochrome interaction increase the length of conjugation and hence decrease the energy required for the transition. Therefore, the increase in the wavelength of the absorption of the light is called as batochromic shifts. If the chromophore and chromophore-oxochrome interaction increases the length of the conjugation and hence decreases the energy required for transitions, therefore the increase in the wavelength of absorption of the light is called as batochromic shift. Wavelength, if you draw the graph, on the graphs one side is the wavelength, on the other side is the intensity of absorptions, and the graph is given a wavelength, intensity of absorptions and wavelengths in the batochromic shift increases, means it increases in all the sides. So therefore the increase in the wavelength of the absorption of the light is called as batochromic shift. Wavelength of absorption of the lights means batochromic shift. It is indicating here that the parameter, this is the wavelength, this is the intensity, and intensity is also increasing in this way. Absorptions of the intensity, wavelength is also increases in this way, means the both are the increases, the shifts, the absorption of wavelength increases. Next one example is here given. Best example, that is lambda max absorptions values are indicated in the lambda max values. So lambda max depends upon the conjugations. The lambda max value for the benzene ring is 254 nanometer. If you do the batochromic shift, means that we attach the any oxochromic groups or chromophoric groups to that benzene rings, means it increases the conjugation of that structures, then the lambda max value is ultimately increases, that is the lambda max for the phenol is the 270 nanometers. Next, we again in Batochromic shift means again increases the conjugations by increasing the groups, that is whether it is a Exochromic groups or chromophoric groups attached to that benzene rings. So it is a nitrophenols. It is the nitrophenolic groups. And so these are the structures. The value of the nitrophenol is the lambda max is a 318 nanometers. 318 nanometer. Next is the question 4. Define the terms Hipsochromic shift and Hyperchromic shift. Question number 4. Define the term Hipsochromic shift and Hyperchromic shift. So in case of Hipsochromic shift, the presence of certain groups decreases the wavelength of the absorptions due to decrease in the conjugations. You know that if any compound showing the conjugations and that compounds is attached with the chromophoric groups that having the some conjugations, but if you attach another chromophoric groups to that particular compounds, means the chromophoric groups is in general is electron withdrawing groups. So if there are two chromophoric groups attached, means from the two sides electrons get attracted, each means the delocalization decreases. If any compound attached with one oxochrome and another chromophore, then the conjugation is increases. But if a compound attach both sides, that is chromophoric groups, then the conjugation decreases. And as the conjugation decreases, means the decrease in the absorptions of the wavelength, means the wavelength of the absorption is also decreases, means the lambda max value is also decreases. So the in the conditions it is called as Hipsochromic shift. It is called as Hipsochromic shift. The presence of the certain group decreases the wavelength of the absorptions due to decrease in the conjugations. Thus the more energy is required for the transitions. Therefore absorptions takes place towards the shorter wavelengths, and this is called as Hipsochromic shifts. So the lambda max value is 270 nanometer nitrobenzenes, lambda max value 261 nanometer para nitrobenzenes. So in this case we can draw here the wavelength and the intensity of absorptions. Okay, so in this way here is the some mistakes in the diagrams, I think, because the due to a Hipsochromic shift wavelength or intensity of absorption is decreases, means it should be only of two types, that is it can decrease here, it can decrease here, this is not, this is not. In the next, by decrease in the length intensity of absorption, which is called as Hipsochromic shift, that is a Hyperchromic shift. Intensity of Hyperchromic shift means in these directions Hyperchromic shift increases. So next question is the explain the ortho and para nitrophenols. Explain the ortho and para nitrophenol. Show the intense yellow color in the alkaline medium. Show the intense yellow color in the alkaline medium. Intense yellow color means compound in general shows the some faint color, but if it is deep into the alkaline medium, it is gives the intense colors. Means there is a changes in the structures, that changes structure give the sharp color. So ortho and para nitrophenols shows the dark colors in alkaline medium. Ortho and para nitrophenol shows the dark color in alkaline medium. In alkaline medium, they form the salt which has many charge resonance structures. In alkaline medium, they form the salt which has many charge resonance structures. They absorb strongly in visible region. They absorb strongly in the visible region, causing deep colors. His example is orthonitrophenol. Its color is the pale yellow colors. When it absorbs in presence of the base, it changes orange red color, that is sodium salt. Because as we dipped in the alkaline mediums, it's converted its structures and changes sodium salt from the sodium salt of, and sodium salt is gives the sharp color. So the ortho and para nitrophenol show the dark colors. In the alkaline mediums, in alkaline medium they form the salt which has many charge resonance structures. Resonance structures increases due to the formation of the sodium salt of the orthonitrophenol. So due to this charge and due to increase in the resonance structures, in alkaline medium they form the salt which has the many charge resonance structures. They absorb the strongly in visible region, causing the deep colors. So here is the orthonitrophenol gives the deep colors and the sodium salt. Another example is given here, that is para-nitrophenols. Structure of the para-nitrophenol is the para positions nitro groups to the OH groups. If deep in the alkaline mediums, that is sodium hydroxide, again it NaOH is the strong base. The strong base abstract the protons which is present at the OH groups, that is phenolic groups. So after abstraction of the protons, oxygens become O negative anion, oxyanions, and H plus ion removed in the form of H2O. So oxyanions are stabilized by the formation of bond with the metals. So the sodium salt is formation there, and that sodium salt is also dark in colors. So this is all about these two terms, that is the Hipsochromic shift, Batochromic shift, and chromophores. Once again, Batochromic shift, the chromophore and oxochrome interaction increases the length of the conjugations and hence decrease the energy required for the transitions. Therefore, the increase in the wavelength of the absorptions of the light is called as Batochromic shift. Here is the diagrammatical representations. One axis we taken as the wavelength, another axis we taken as the intensity of absorptions, so it is increase in the both sides. His examples, benzenes, as the Batochromic shift means any group attached in the wavelength increases from the 254 nanometer to 270 nanometers, that is from benzene to become the phenol. Then from phenol we again attach on a group, that is chromophoric groups. Then it changes from the 270 nanometer to 318 nanometer. That is the big difference of the 48 nanometer increase only because of the chromophoric group attached to the already oxochromic group there. Means the conjugations is increases, and too much increase in the conjugation increases the wavelength of the groups. So next is the next term is the Hipsochromic shift. The presence of the certain groups decrease the wavelength of the absorption due to decrease in the conjugations. So decreasing conjugations, how will decrease? If there is already one the oxochromic groups, we attach another oxochromic groups, means it decreases the wavelength of that compounds. Thus the more energy required for the transitions, therefore absorption takes place toward the shorter wavelength, and this is called as Hipsochromic Batochromic Shift. So this is all about these structures. Here we are given the wavelength, that is lambda max for the nitrobenzene is the 270 nanometers. If the para-nitrobenzene is there, then the lambda max value should be increased, and it is increased from 270 nanometer to the 261 nanometer, means it is increased by 9 nanometers values. Definitely decreases the absorption of the wavelength. And there, by increasing the intensity of absorption, which is called as hyperchromic shift, also there. Next one is the ortho and para nitrophenols, shows the intense color in the alkaline matter. Reason is only that when alkaline medium having, that is sodium hydroxide, having the sodium Na plus positive charged metal ions, and OH minus ions is basic in nature, so it's a strong base. It abstracts the protons from the phenol and it forms the sodium salt of that particular phenols, and that sodium salt of particular phenols, when you having the charge resonance, many charge resonance structures, and they absorb strongly in the visible region, causing the deep colors. So this is all about two studies of the dyes. We will meet in the next lecture with the new topics. Thank you very much.